Hey guys, welcome to our first lesson of distance learning. We are beginning chapter 13, graphing and writing linear equations. Chapter 13.1 is just graphing linear equations. However, as you can see today, we will be writing a little bit and we are also graphing linear equations. So remember, you guys can pause the video at any time. I won't even know. I won't be offended. Pause the video if you think I'm moving too fast. All right, I recommend you guys taking notes. So no worries if you're pausing the video. I just don't want the video to be too long. Okay, so we're mostly going to be graphing linear equations. However, we're going to write a linear equation first. So let's just look at different things that make up a linear equation. Well, the word linear kind of sounds like a line, right? Well, a line is straight, which means linear equations are always a straight line. Next, notice how many ordered pairs do you guys see on both of these graphs? Two, right? You need at least 2 points to make a straight line, right? If you have a point here and a point here, you can make a straight line. You can make a different straight line if they're different points. You just need 2 points to make a straight line, right? Also notice between those 2 points that we have, you can create a slope. Remember how we talked about slope in chapter 5? Slope is just how to get from one point to another point. So let's first look at how to get from this point to this point, right? Notice we go up 1 and we go to the right 4. Now remember, slope is rise over run. So slope, which we call m, so I'm going to put rise over run, which just equals, we're going up 1 and over 4. So your m equals 1/4, right? Slope is really important in linear equations. We're going to go over that next section. Another part that's really important is the y-intercept. Y-intercept is anything that crosses this y-axis. So notice we have the point right here. So our y-intercept is 0, 2. So we just write 2. Therefore, our equation, we always put y equals. Notice our m is 1/4, so we're going to put 1/4, and we're going to connect it to the x, because you're going up 1 over 4, up 1 over 4. So that's the part that's changing. So it needs to be attached to a variable. So 1/4 x, and now our y-intercept is a fixed point. It's not changing. So you just put it at the end, plus 2. Like I said, we're not really going to be working with this as much today. However, we will in the future. So it's good to get a sense of what a linear equation looks like. So it will always have a y and an x, and then it usually has one other point that doesn't really move. Okay, let's look at this next one. So notice we're going up 1, 2, 3, 4, 5, 6, 7, and then to the right 2. So up 7, to the right 2. So that means our slope, we rose 7, we ran 2. Now do not change this to 3.5. If you put 3.5, that's wrong. Remember, slope is always a fraction, numerator and denominator, because it tells you how much to run and how much to rise. So leave it as 7/2. Now notice right here on the y-axis, we have a -2. So our y equals -2, our y-intercept. So therefore, our equation is y equals 7/2x. And now we have a -2 this time, so we just put -2. Hopefully there's no questions on that. If not, you can rewind. Remember, I am available during office hours at certain times, so just hang loose till then. But I think you guys can understand. And again, we're not really doing this today. We're just going to be graphing them. We're actually going to move opposite. We're going to be given these two equations, and we're going to create the graph. So let's move to our next slide, example 1. Like I said, we're just graphing. So we're going to graph y equals 2x. Now I have 1, 2, 3, 4, 5, 6 different spots to put values. However, you only need 2 values to create a straight line. Any 2 values will make a line that is distinct, that is different than any other line. So you only need 2 values. First, I'm going to do a little bit more. I'm going to put 3 or 4, right? Just to show you that it doesn't really matter. Now, the most common point to always put is a 0. So under the x spot, I want you guys to put a 0. What we're essentially doing, we're going to plug in x values, and it's going to spit out a y value. For example, if I plug in 0, then that means y equals 2 times 0. Well, 2 times 0 is just 0, right? Second number that I'm going to put is a 1. 1's pretty easy. So then I'm going to do 2 times 1, and 2 times 1 is just 2. And then I'm going to put a -1. I think -1's pretty easy too. So 2 times -1, 2 times -1 is just -2. So I could put more points, but I don't need to. Remember, I only need 2, and I did 3. So our 3 points here are 0, 0. So I'm going to put 0, 0. I'm going to put 1, 2. And then I'm going to put -1, -2. All right, I think that'll do. All right, so those are our 3 points, and notice how we just created a straight line. So now I'm going to connect the straight line. Boom, draw some arrows at the end, and we are done. This is the equation y equals 2x. Notice there is no y-intercept, which means that y-intercept hits at 0, which is perfect, and a slope of 2. Notice we went up 2, and we went up 2, and we went to the right 1. Therefore, our slope is 2. Hopefully there's no questions. We have about 3 or 4 more examples, so let's just dive right in to the next example. Ooh, this slope has a fraction. That's okay. That just means you want to pick better values for the x to plug in. So one number that you always want to plug in, you want to plug in 0. So first, let's plug in 0. I'm waiting for my thing to load. But if we plug in 0 to the x, then we get 1/2 times 0. Well, 1/2 times 0 is just 0. So we're going to have our first point, here we go, of 0, 0. So I plugged in 0, and now 1/2 times 0 is 0. Now, I could plug in the value 1, but notice 1/2 times 1 is 1/2, and that's kind of hard to write. So we don't really like that. Instead, what I'm going to plug in is the number 2. The reason why I'm choosing the number 2 is because of the denominator 1/2, the denominator of 2. So notice I could do 1/2 times 2, and those cancel out, and I just get 1. And I could also do -2, and it would be 1/2 times -2. Those cancel out, but 1 times the -1 is just -1. So I can plot my points of 0, 0, 0, 0, 2, 1. Yeah, how it does that. 2, 1. Here, let's make it a little bit thicker. 2, 1, and then -2, -1. Right? So now we're going to have those 3 ordered pairs, and let's see. Well, that's not -2, -1. That's -2, -2. Right? So we need -2, -1 if it's going to allow me to write it. There we go. Now notice we have a straight line. So what I'm going to do is create a straight line between the two. Don't forget your arrows at the end. Whoa, that's pretty thick. Let's make it a little bit thinner. And then we have our straight line, right? Notice you rise up 1, and then you run 2, which is a slope of 1/2. It crosses 0, 0, which means the y-intercept is 0. All right. Example 3. Example 3 is a little bit more difficult. It's 3/4 x minus 5. That's pretty tough, right? So like I said, one point that you always want to use. Oh, wait. One point that you always want to use is 0. So go ahead and plug in 0 to the x and see what your y value is. My thing is loading right now, so just give it a couple seconds. But you're going to plug in 0, and you're going to get a y value. Whenever you plug in 0, that's automatically going to give you your y-intercept. If you plug in 0, that means you're not moving left or right on the x-axis. You're only moving up and down on the y-axis. That's your y-intercept. So if you plug in 0, you get 3/4 times 0 minus 5. Well, 3/4 times 0 is just 0. 0 minus 5 is -5. So we're going to get -5 right here. There we go. Now, if I plug in 1, I get 3/4 minus 5. That's ugly. If I get 2, I get 3/2 minus 5. That's kind of ugly too. Let's plug in the number 4. The reason I choose 4 is because of the denominator. Look, 3/4 times 4 minus 5. Those 4's cancel out. We get 3 minus 5. 3 minus 5 is -2. 2. So we get 4, negative 2. There we go. Now, remember, like I said before, you only need 2 points to create a straight line. I could have chosen negative 4, but if I chose negative 4, that would be negative 8. Negative 4 would give me negative 8, and that's not quite on here. It would be somewhere down there. So I guess I can put it, however, it is a little bit uglier. So I'm going to draw a straight line, and then I'm going to connect arrows, right? And then that is our linear equation for y equals 3/4 x minus 5. All right, guys, 2 more examples. You guys are doing pretty good, I think. Don't really know. Maybe 3 more examples. This one, notice this one, it has a negative slope, right? A negative slope means instead of us rising, we are going to be decreasing, right? It's still rise over run, but we're just rising a negative amount. So notice the line will be in a different direction, all right? So give it a sec for my thing to load, but you guys can go ahead and begin doing this if you guys want. Negative 1/3 x plus 2. And I need to do this again. Let my thing will load. There we go. So negative 1/3 x plus 2. So remember, plug in 0, and then plug in the denominator as your second number. That's always the best case. Notice, if you plug in 0, you just get the value of 2. So you get 0, 2. You get 0, 2. If you plug in the value 3, then you get negative 1 plus 2 is a positive 1. 3's cancel out, and you're left with negative 1 plus 2, which is positive 1. And then plug in negative 3. You don't have to, but I like to plug in 3 values because it's an easier straight line to see. So negative 3's, the 3's cancel out. Negative 1 times negative 1 is positive 1. So negative 3, 3. Notice when I graph this, I get 0, 2, 3, 1, and then negative 3, up 3. Notice that is a straight line, right? But notice we are decreasing now. The line is going the opposite way. First it was like this, now it's like that, or maybe it's the other way around, right? Depending on how your screen is. So let's draw a straight line. Let's see. Perfect, beautiful. Hopefully yours is as good as this. But there you go. That's going to be your linear equation for negative 1/3 x plus 2. And the reason I know that's right is because if I change this to red, then I go down 1 and to the right 3. So minus 1, 3. That means m is negative 1/3. Notice on my y-intercept, it crosses at 2. So the y-intercept equals 2. Look, negative 1/3, 2. I know I've done it right. All right, let's go to example 5. Example 5, y equals 3. Now, we have y equals something. Our next example is going to be x equals something. These are always the most difficult ones. Y equals 3 is either a horizontal line or a vertical line. Now, most people think y equals 3 is a vertical line because you associate y with the y-axis as vertical. But that's not the case. Y equals 3 is actually a horizontal line because remember, y is the height. That means the height is always 3. So if you have a horizontal line right here, the height is not changing. It is the same right here as it is over here, correct? If we had it vertical, these are 2 different heights, but we need the height to be consistent at 3. So what I'm going to do here, I know this seems weird, I'm going to plug in the number 0. Remember, like I said, always plug in 0. So I'm going to plug in 0 for x. So I put 0 for x. Now, is there anywhere to plug that 0 in? No, there's no x. So that means y equals 3. It tells you y equals 3. I'm going to plug in 1. Well, y equals 3. We'll plug in negative 1. Well, y equals 3. Plug in 2. Y equals 3. It doesn't matter. So when I graph this, I go 0, 3. I go 1, 3. Negative 1, 3. 2, 3. I could make an infinite number of these, right? But notice, this will create a horizontal line. I'm going to draw a horizontal line at y equals 3. So whenever you have y equals just a number, that is a horizontal line. I know you want to think vertical. I thought that while I was in high school for a long time, right? I always got it wrong. But when you actually plug in the points, you'll see that y is consistent. The height is not changing, so it's flat. There is no slope, right? There's absolutely no slope. All right, let's go to the next example, our last example for the day, x equals 4. So now, x equals 4. Remember, x is left and right, right? That is not changing. That means we have a vertical line. The length, the horizontal line is not changing. You're not going in different positions. You are in one position. Since you're in one position, you're fixed at 4. That means your height can change, but your horizontal cannot change, right? Your distance side to side cannot change. So that means I'm not allowed to plug in any values for x. X has to be 4, right? X has to be 4 no matter what. So instead, let's pick random values of y. So for y, I'm going to pick 0. If I pick 0 for y, well, x is 4. If I pick 1 for y, doesn't matter, x is 4. If I pick 6 for y, does not matter, x is 4. So if I graph this, we have 4, 0, we have 4, 1, we have 4, 6. Look at that, a vertical line. Your horizontal distance is not changing, right? You are in a fixed position at x equals 4. The y value could be whatever you want it to be. It doesn't say specifically what y has to be. It could be anything, but x has to equal 4. I'm going to draw a straight line. I'm going to put my arrows. Done, right? These examples really aren't that bad, guys. All right, last slide, renting a limo. And I was way off. I thought we only had a couple more examples, but it turns out we got a few more. Now, unfortunately, this one is a little bit more in depth. It's not too bad though, but I promise you it is our last example. All right, so it costs $200 to rent a limo, an additional $20 per hour afterwards. Write and graph this equation. So this is a little bit of everything that we've done today. So now, it costs $200 to rent a limo. So before you even get into the limo, you're spending $200, right? It's kind of like a gym membership. You pay, if you go, doesn't matter, right? You're paying already, right? So it's $200 to rent a limo. That's the front cost. Just to get in the limo costs $200. So that means if you go in the limo for 0 hours, you're still spending $200, right? It doesn't matter if you go in. However, if you go in the limo for 1 hour, it's additional $20 per hour, right? So that means it's not $200, it's now $220. If you go in the limo for 2 hours, it's 240 hours. Notice you're increasing $20 per hour. That's what this part means. An additional $20 per hour afterwards, right? So as we increase 1 hour, we go up $20. Now we have 3 points here, so let's graph. So 0, 200 is our first ordered pair. Next, 1, 220, 2, 240, right? And so on. So when I draw my line, wait, do I draw a line? Right? That's the interesting question. Yes, draw a line. So when you draw a line, do not go past. You can't have negative hours. You can't rent a limo and say, I'm going to use it for negative 3 hours. That doesn't really make sense, right? So we're going to start it at 0, kind of like a ray, where a ray goes on forever in one direction, but not the other direction. It stops. So we're starting at 0 hours and we're moving forward hours. So this is going to be our linear equation graphically. Now let's write it. So a few important parts. One important part right here. You guys see that important part? That is the y-intercept. So that means the y-intercept, since it's at 0, right? Since it's on this line right here, the y-intercept is going to be 200, right? Okay, can this work, please? 200. The y-intercept is 200. Now, let's figure out what our slope is. So our slope, remember, it's rise over run. So we're going from 220 to 240. That's plus 20. And then we're moving from 1 to 2. That's plus 1. That means our slope is going to be, we call slope m. M equals rise over run. So we're rising 20, we're going over 1. So m equals 20. Therefore, when we write our equation, we get y equals, now you put the slope, attach it to the x, has to be attached to the variable, 20x plus 200. Now let's check our work. Plug in 0. 20 times 0 is 20, or 20 times 0 is 0, plus 200, yep, y is 200. Plug in 1. 20 times 1 is 20, there we go, plus 200 is 220. Yep. 20 times 2 is 40. 40 plus 200, 240. There you go. This is our equation. Last slide is your homework. Remember, homework is due this Friday by 11:59 p.m. You can turn it in early, no problem, right? I kind of expect you guys to. Big Ideas, Chapter 13, Section 1. It's just on big ideas. You guys will have unlimited check answers, so don't even worry about it. Unlimited check answer, right? You don't need to copy your neighbor or anything or text your friends. Don't do that, right? Just do the work. You have unlimited check answer. I want you guys to attempt it on your own, okay? Pages 570 to 571, 2 through 32 even. That's if you don't have access to big ideas. If you guys are watching this video, you have access to the internet. That means you probably have access to big ideas. But if you want to show all your work and physically graph it and then take a picture and send it to me for full credit, you may do that as well. However, it's a lot easier online to graph because the graph is there for you. You don't have to draw your X and Y axis and make your points and get graph. So I recommend using big ideas, but if you want to send it to me via email, that's fine too. Remember, it's eshir@wvusd.k12.ca.us. All right, challengers, accelerated students. Hopefully you guys understood this lesson. Remember, I have office hours available if you guys are confused, but you guys have a great rest of your day. All right? Peace. Now peace. Now peace.